Models. We're really excited today to be teaching best practices for as-built surveying, drafting, and modeling. So my name is Cameron Slatterbeck, and I'm the project manager. I head up our SoCal region here at PPM. And then we'll be hearing from Greg Davies a little bit later. He's our director of special operations here at PPM nationally. And he's our resident scanning guru. So he'll be touching on things related to scanning and modeling a little bit later on. And so this presentation is accredited to provide one continuing education learning unit to AIA member attendees. And before we get started, if you could just please sign in to make sure that you do get those credits, go to that URL there at the top of the screen, and it'll be in the chat as well. Or I'm sure we're all pretty familiar with using QR codes these days. You can go ahead and get your cell phone out and scan that QR code, and that'll take you to that form as well, and go ahead and sign in. And so this class is a demonstration of how to procure a proper set of as-built plans when needed for any structure. So it'll briefly cover the reasons they're needed, technique in obtaining that information on site, including 3D laser scanning and traditional methods. And finally, the drafting in CAD or modeling in Revit to suit your design needs. And so some learning objectives. At the end of this course, participants will be able to, one, begin a project by determining if as-builts are needed, understand the scope of work from an as-built only perspective and how that will achieve different goals, to give you a head start on creating design elements, construction documents, and obtaining permits. Number two, obtain as-built plans for all levels of scope through some traditional but also very fundamental methods. Number three, understand new methods for gathering that data on site, such as LiDAR scanning and 3D photogrammetry, which Greg will jump into. And then finally, be able to put down that collected data into both AutoCAD and Revit programs. And so table of contents. So we'll start off with chapter one, which is what are as-built plans? And so we'll go over some common definitions, when as-builts are needed and also when they aren't, gathering various degrees of information and when projects require a detailed scope. Chapter two will be traditional surveying methods. So we'll go over sketching, plan view measurements, the Z-axis, that type of stuff. And then Greg will jump into laser scanning, the new era, chapter three. Going over some terrestrial scanners, mobile scanners, point cloud, using that point cloud. And then we'll be finishing off with chapter four, which is creating an as-built set. So drafting from the traditional method as well as drafting and modeling from the point cloud. And so throughout this presentation, we're going to have a series of polls in which I'll ask you all a multiple choice question. And please, if you could hold all questions till the end, we'll have a Q&A session at the very end at that time, so we can open it up for questions if you have any for us at that time. And so chapter one, what are as-built plans? So some common definitions. So when looking into the actual definition of as-built plans, what one will most likely find is a definition that concerns as-built plans being created after or during new construction or after or during a renovation. So what we found is as-built drawings are prepared by the contractor. They show in red ink on-site changes to the original construction documents. They're more like interpolations done for construction purposes. Therefore, the changes that the contractor makes onto the original design are called as-built drawings. And so contractor developed as-built should not be confused with record drawings created, of course, by the architect or engineer. Record or archive drawings often include the information gathered on site or on as-built and are the final set of formally developed prints, fully signed and stamped by the project engineer. So this definition reads, record drawings are prepared by the architect and reflect on-site changes the contractor noted in the as-built drawings. So they're often compiled as a set of on-site changes made for the owner per the owner-architect contract. So this set is not always mandatory or created, but in general, some formal architectural services create these as one of the last tasks of a building project. And so our first poll here, and let's see if we can figure this out. My first question is, how many times has a contractor you've worked with actually created as-builts for you as described? And so our options are A, never, B, sometimes, or C, always. And let's see if we can relaunch this. And I'm hoping everyone sees that. And I'm seeing the votes pile in here. A lot of A's and B's, not too many C's. We're going 2 for 38 so far. 5% of votes or answers are saying they always get these as-builts from contractors. And I'll keep this up for another few seconds here. We've got about 80% participation, so getting some good feedback. Pretty split between never and sometimes, though. All right, looks like we've stopped, so I will end that poll and share those results. So like I said, it's pretty split, 20 versus 22, never versus sometimes, and then 3 Lone Rangers say that they always get these as-builts from their contractors. So I will stop sharing that one. We will move on. Oops. So again, what is an as-built plan? I'd say let's just keep this simple. I think we can all agree that, simply put, in the architectural and construction industry, as-built refers to a drawing that shows the existing dimensions and conditions of a building, space, or area. And so before we get any further, I want to say that throughout the presentation, we'll be discussing producing as-built plans in their final format as either 2D CAD files or 3D Revit model. Both are types of software created by Autodesk. As you likely all know, there are many other types of drafting and modeling software out there. So even though we mentioned, Autodesk software throughout this presentation, it's likely that you can still apply these points that we make about 2D drafting software to all others on the market, as well as other types of 3D modeling software. So what are the contributing factors when as-builts are needed? So pretty much whenever we're working with an existing building, we need as-builts before starting design. And so if the owner or client happens to already have as-built drawings, then we may just need to enter them into CAD or reformat them if they're already in CAD and confirm that the drawings are actually up to date. So if errors or inconsistencies are found, then at some point you may need a fresh set. And then what are some contributing factors when as-builts actually are not needed? And so it is rare that clients already have current as-builts of their existing buildings that are actually accurate, but it does happen. And so in that case, of course, you would not need more as-builts before starting your project. There are also simple cosmetic projects that do not require having accurate as-built plans. And of course, if a building is being built from scratch, then all you'll need are those construction documents. And so when is the best time to obtain as-built plans? So in most cases, obtaining as-built files is one of the very first steps in the renovation process, if not the very first step. So getting ahead of this step also, it allows an architect to focus on their expertise, design, plan creation, and submittal to the building department, all of which, as you all know, are considerably more time consuming than that first step of actually, putting together the as-built plans. So there are also cases where you'll be working with maybe the historic review and they'll require as-built plans to be created. Most engineers will want a fresh and accurate set of as-built plans before they begin maybe a seismic retrofit. If you're working on a teardown project, some building departments even still require you to submit as-builts of those structures that are being demolished. And so as mentioned on the previous slide, different municipalities work differently and have different requirements. If they require as-builts for any reason, the type or the scope needed may vary from city to city. So if you plan to preserve or improve upon detailed architectural elements such as ornamentation, You'll need to consider that documentation and where it fits in your overall timeline. Overall, the size and scope of your project will determine when as-builts are actually needed. And as we'll discuss in the next section, to what degree the detail and scope of as-builts that are actually required. And so you've discovered that you're actually going to need as-builts. How far or in how much detail do you need that information to go? And so above are a few examples of plan types and when they're needed in your as-built plan set. So you might need a floor plan, for instance. That's almost always going to be needed if you're doing any interior work of any kind. Exterior elevation is another common one. Basically, anytime you're doing any work that impacts the exterior facades of the structure, you're going to probably want exterior elevations. Sections, another one. So if you're working on an existing structure where there might be maybe some city, height constraints that you're working with, or maybe those interstitial spaces such as attics, basements, crawl spaces, section cuts are a good go-to. And then RCP, reflected ceiling plans. Maybe when you're modifying existing lighting, but maybe not replacing it completely. Where there's unique ceiling conditions that you're working with, such as copper ceilings, soffits, exposed structural members, things like that. So ways to gather different degrees of on-site information. So before we get into specifics regarding plan types, let's go over some of the ways to gather some of that on-site information, starting with a very simple, quick method, and then ending with full-blown as-built plans. So now we know what we need and why we need it. And now let's talk about how do we actually get it. So photos. So that's the quickest, easiest way. So one way to obtain the answers that you need on site before renovation is by simply taking those photos. So this can assist in the design process and answer questions you might have before proceeding. Next would be like a single line drawing diagram. So sometimes a quick single line or even a bubble diagram is all you might need to achieve your goals. This can be achieved quite quickly on site and does not need to be to scale. And now we're getting into sketching. So this can be very helpful in supporting your design. In the case of interior elevations, maybe or perspectives, this can also be done roughly and may not require actual measurement. And then finally, measuring. If drawings need to be to scale, such as when they'll be used to create new construction documents, then you'll need to go to a higher level of accuracy and measure those existing conditions. So most remodel projects require a more detailed scope for as-built. So this will give you a head start in the creation of your design, submittal, and construction documents. And so to sum up the first portion, chapter 1, understanding as-builts. As-built plans, simply defined, is a set of plans of any structure as it exists at that moment. So they're most often used for a renovation of some type. Also, getting as-built drawings in the format in which you work is incredibly important, such as a particular software. And then finally, the scope of the as-built plans and the detail of each scope item will vary with the needs of your project. And so now we'll jump into chapter 2, which is traditional surveying methods. So we'll talk about an as-built production method first off that's near and dear to many of our hearts here at PPM, and that is sketching, having done that for many, many years now. So here's how you might sketch. Remember that sketching does not need to be to scale. All you need to do is make sure that there is room to write the measurements that you need, and that is visually easy enough to follow once you're back in the office. So using things like different colors to mark different measurements and drawing types is super helpful, just so that your eye will catch each segment accordingly when you're drafting, and that you don't have to spend so much time kind of hunting that down on the sketches for what you need at that time. Get as much sketching done as you can before measuring is highly recommended. So just so that you can focus on measurement when the time comes and simply execute. The better your sketching is, the easier your measurement will be. If sketched correctly, any structure can be measured much, much quicker. So also leave room to write in measurements later on. Plan ahead to get your heights or measurements on the Z-axis. Most of the time, this information can still be displayed in plan view, but occasionally you'll want to sketch in section or elevation view as well. So we'll talk about this again in the next few slides. And finally, sketch out any details or ornamentation to the degree of precision you desire to be able to add those measurements later on, like I mentioned. So now it is time to add measurements to your sketch. And so an important step that many people I've noticed skip when measuring a structure is going around the exterior faces. So often a wall thickness at an exterior wall is taken a single measurement and then simply going inside and taking all interior measurements from there. But we consider this step to be incredibly crucial. So start with that perimeter, measure all the lengths and go 360 degrees around. And a quick tip here to check your work, add up all of the X values and all of the Y values, as you see at the bottom right of this sketch here. So if the sum of all the X values on each side of the building add up to the same number, or at least very close, then you're definitely on the right track. And go ahead and do that for the Y values as well. So in this sketch, you may notice that there are some overall measurements as well as some small incremental measurements. This is a good system of checks and balances that will not only improve overall accuracy, it may save you in the event that you have an incorrect measurement or notation. Don't forget to get good photo coverage. That's huge. That'll help you verify that what you actually are drafting is indeed correct. Occasionally, we've seen errors that don't appear, right away. Or on paper, but are obvious once you start getting into the images, and they reveal themselves very quickly. And so as you can see, this image shows the previous sketch, but with a sheet of vellum over it. So this allows us to use that same information from the first sketch as sort of a template, such as wall layouts and things like that. And then you can add even more symbols and measurements above that and not need to actually resketch all those walls, doors, windows, things like that. So bring that vellum. This can also be helpful if you need to add items that you're out of room to sketch them or write those measurements down. This is also really useful just when you're adding detailed items like electrical faceplates, cabinetry, and reflected ceiling fan items as well. And so now let's talk about collecting the Z-axis measurements or height information using traditional methods. So you can use a tape measure, as we all know, to measure all the risers and stairs, for instance, maybe drop it down a balcony, run it up a wall, things like that. A laser distance meter or disto can perform trigonometric functions instantly and get you heights in all sorts of ways. The first two of these tools you might already be using to measure all other aspects of your plans, but the third is used exclusively to gather height information, and that is the zip level. And this is an excellent tool that we've been using for many years. It's invented, distributed, and repaired if needed by a company out of San Diego. And I'm actually not aware of any other version of this tool, but it basically uses displacement to read heights anywhere within a 50-foot radius. So this is super helpful when you're measuring over large spans of distance. And so however you've collected your height measurements, make sure that you've got them in the places that you're going to need them. So most of the areas will be obvious, like the tops of any steps, staircases, floor to floor heights, changes in finished floor height. Like you see there in that sketch, you've got some steps down and a stairwell going up to the next level. And then plan on what you'll need to see in those exterior elevations and sections. So make sure you have either some basic height and good pitch information for your roof, or if it's safe to actually get up on the roof, gather as many heights as possible while you're up there. Make sure not to forget the heights of openings, such as windows and areas you plan to show, or the heights of items like wall sconces, for instance, if you plan to produce detailed interior elevations. And so to sum up the second portion of this presentation, traditional surveying methods. So overall, having the perfect sketch isn't what's important. What you do need is a sketch that displays and contains all the measurements you'll need in drafting. you need to encapsulate the structure by measuring all the way around it. This will give you the scale when you begin drafting and ensure your interior measurements are correct as well. And finally, after taking those measurements of more major items like walls, doors, and windows, move on to that next level of detail as needed. This can be for cabinetry, plumbing fixtures, electrical, and ceiling components as well. And so now we have, I believe, our second poll. And the question is, how comfortable are you with sketching and measuring as-builts? And so we have A, very uncomfortable. It makes me sweat just to think about it. B, I've done it, but I don't like it. C, I am comfortable doing this. Or D, I always sketch and measure my as-builts, and I love it. And I'm going to go out on a limb and think that we're not going to get many answers to D, but we'll find out here very soon. So I just launched that poll, so start voting away, and we'll see how the results go. Only one person very uncomfortable. They get very sweaty when they start doing their own as-builts. We've got some more answers to D than I thought. And I'll keep this open for another couple seconds here. We've got about 3/4 of you have participated in this survey. All right. So for the most part, B, I've done it, but I don't like it, or you're also pretty comfortable doing this. Most of you, actually, the majority. That's interesting to see. And then we have 6 people who they love it. And then the one lone ranger, like I mentioned before, they're very uncomfortable doing. Always interesting to see those answers. And so now I will kick this to Greg, who's going to go over laser scanning. Take it away, dude.
Awesome. Thanks, Cam. Well, I guess I have to admit that I was that one lone ranger that says I sweat when I think about having to do it. So I might have been skewing the data set there a little bit. But that's largely because I've just gotten so used to laser scanning that even though I did it that traditional way for so many years, yeah, just it takes me back to the good old days of using that method to get all my plans. And I do miss those days sometimes, but I am looking forward to talking to all of you about laser scanners, or LiDAR, and point clouds to gather as-built survey data. All right. So updating or even replacing a proven method for doing something to utilize the newest technology isn't easy, no matter what industry you're in. The first step you take, though, is the most important, and the rest is hard work and diligence. Even though it may be difficult to transition, making the change to laser scanning as a survey method provides you with fast acquisition of as-built data using 3D laser scanners that utilize LiDAR technology. The more accurate than any measurements that can be taken by hand, it reduces the odds of human error. Technology that can be purchased, rented, or contracted as a service. A thorough solution that allows you to gather more data than needed to complete drawings and models for most projects. And then what we call a digital twin of any property that allows you to basically visit the site from the comfort of your office, and then eventually pull additional data if the scope of your project changes after you complete your first set of plans. So I want to talk a little bit about just the 2 different main types of terrestrial laser scanners. The first is a terrestrial, which is a stationary. The second is a mobile, like the GeoSlam Z Revo, which can be moved while scanning. So the terrestrial scanner, the reason it's stationary is it sits on a tripod and it spins to gather 3D data from that one single position. And then after scanning hundreds of individual positions with good overlap in between, you can bring all that data together into one big data set for your project. Whereas the mobile scanner, it allows you to get to a similar end result of that big data set, but it does that by utilizing an algorithm called SLAM, which stands for Simultaneous Localization and Mapping. And then the scanner and the accompanying software allow you to gather the 3D data while simply walking through a space. And this dramatically reduces the amount of time needed to capture data in the field. So no matter what scanner you use, each scanner uses LiDAR to create a 3D data set called a point cloud. So LiDAR stands for light distance and ranging, similar to radar, which stands for radio distance and ranging and uses radio signals to measure that distance. This is a method for measuring distances by illuminating an object with a laser and measuring that laser beam's reflection with a sensor. And each one of these reflections results in a single measurement in space. And then as each single measurement is logged, throughout the course of the scan, millions of measurements are taken in all directions, and that creates a cloud of points, or a point cloud. Okay, so first let's talk a little bit more about a terrestrial scanner that we like to use in the field. And that is Leica's RTC 360. So as mentioned, this is a terrestrial stationary scanner, and overall you'll find that the terrestrial scanners like this one give you much cleaner and much denser point cloud than a mobile scanner will. Even though this needs to be set up on a tripod, the individual scan times for the RTC 360 are relatively short compared to other terrestrial scanners, making it the fastest terrestrial option out there. The iPad app also helps make sure that you can check your point clouds before leaving the job site. And even though the RTC is extremely precise, there's other terrestrial scanners out there that offer even higher levels of precision in their resulting point clouds. So in the next slide, we'll see a short video of what a point cloud looks like from a single family residence taken with this scanner over in Laguna Beach. So as you can see, this scanner collects a lot of data on everything within the view of the scanner. The RTC picks up color as well, and it really is a great tool if you need to capture complex architectural ornamentation, detailed structural members, or MEP piping and equipment in any kind of significant detail. Okay, so that was just a quick little run through of terrestrial scanners. Now I want to talk about the mobile scanners. While the terrestrial scanners do make great looking data, these are the scanners that we're most familiar with here at PPM. And that is the GeoSlam Zeb Revo. So the trade-off for a less colorful point cloud or a hyper level of precision is that with a mobile scanner, you greatly reduce your time on site taking measurements because the scanning is done continuously while walking through a space and does not need to be mounted on a tripod. Even stacked up against the Leica scanner we just discussed, 3 hours of scanning can be cut down to 15 minutes with a mobile scanner like this one. These scanners are also very modular. You can mount other equipment to them, like a GoPro camera, and you can even mount the scanner itself to a drone. So next, we'll watch a short video that shows the output from a scanner like the one you see here. So here you can easily see that even though there is no photo-based colorization of the points on this little villa here, these points are still colored on what we call a height ramp, where points at different heights are shown at different colors on a spectrum, which you can see on the left. Red is a lower height and blue is a higher height. So coloring the points this way just makes it easier to see important features in the point cloud, even without that photo colorization. So to wrap up using mobile scanners in the field, using a mobile scanner is preferable if your time on site is limited. Once the scan is complete, you'll need to use the SLAM algorithm software, which interprets all the measurement and movement data from the scanner and produces the 3D point cloud. Since most individual scans take only about 15 to 45 minutes, this gives you more than enough time on site to process the scan and to check your results before you leave. And reviewing your point cloud on site is essential to ensure accuracy. Most errors in scanning or processing can be spotted pretty quickly, and actions can be taken right there in the field to help ensure the overall accuracy of your project when it comes time to draft or model. Okay, so we've talked a lot about the point cloud at this point, but let's dig in a little bit more about what a point cloud is and what to look out for before bringing it into your favorite CAD or BIM software. So reviewing your data, as we discussed, reviewing your data very, very closely before attempting to create a set of as-built plans from a point cloud is an absolute must. If there are any errors within your cloud, which can happen, using that bad data can either stop you in your tracks later when you're drafting or modeling, or even worse, result in an incorrect set of as-builts. So some things to look out for. Did you cover all areas? Did you make sure to get the scanner in each room and in each of the areas where you need it? Are there any flaws or errors in the data, things that just don't look like what you remember while you were on site? And most importantly, do you see any drift in the data? So drift is important to keep an eye out for because it's very common, particularly with mobile scanners, and it occurs in a number of situations where the algorithm that processes the scanner data doesn't have enough information to keep the resulting point cloud data in the right place. So in this instance, in the photo on the slide, the surveyor wasn't able to walk a full loop or traverse around the entire building to help the algorithm lock in the accurate perimeter. And you can identify that by seeing that kind of big dark spot on the right side in the point cloud data. That just shows that there wasn't really any data there and helps us understand that that was what was causing this drift. So determining the reason for the error is crucial to informing your decision on how best to reprocess or potentially even rescan your project. That said, some scanners are better than others at different types of projects, but all scanners run into challenges in creating good point cloud data in certain field conditions. So when scanning attics or foundations, those are kind of small cramped spots, but even large sites or big multi-level structures, you may run into issues getting all your data to fit together. Areas that are hard to access have lots of reflective surfaces or have fewer unique features like a repetitive office hallway or big open and empty spaces. All of those can pose a challenge. So processing scan data requires that all areas have data connecting one area to another, like good overlap between data, so they can be properly glued or stitched together. Mirrors or large moving objects or a lack of significant features in your environment can sometimes trick the algorithms and make it a little bit of a challenge to put together a successful point cloud. So most scanners have a range of hundreds of feet, and this can produce a lot of data outside of your project that you don't need. You may sometimes need to clip or crop your point cloud to reduce file size and get rid of some of that unwanted data. If you do have to produce multiple point clouds for a large or complex project, it will be important to get comfortable with point cloud software that will allow you to merge your clouds and more easily manage your point cloud data. So much like the traditional method that Cam was talking about of sketching and measuring, properly scanning a structure takes lots of practice to do correctly and efficiently. But once you are practiced with scanning and know what to look for when errors occur, you will have the most reliable set of data you can gather in the field. You can be confident then that the as-built plans you create will be fully accurate and ensure a smooth and safe renovation. Okay. So you have a point cloud, but now what? Well, now that you've processed and reviewed the outcome of your point cloud data, you'll need to do one of the following two things. Well, first, do it all over again if you found a lot of errors in the point cloud. Your best bet is always to just get the best scan that you can get. Otherwise, if your point cloud data is looking good, you just bring that back to your trusty workstation to dig in with your point cloud. Now we'll dig a little deeper on this in chapter 4, but as a little preview, in order to produce such items as a floor plan, you'll need to get a slice of the point cloud at a desired height and use that view to start your as-built drafting or modeling work. In addition to cutting these slices, you'll want to be able to move and rotate the point clouds to get any view or perspective that you need on the property to perform your work. While there certainly is a learning curve, any CAD or BIM software that supports point clouds can do this for you easily. So to sum things up, scanning your project will prevent costly revisits to site due to errors and will reduce your time spent on site. The type of scanner you use will be dictated by your needs and the level of detail required. And your scanner will create a cloud made of millions of points. Knowing how to manipulate the point cloud in your preferred drafting or modeling software is crucial to using your survey data. And as an added note, while LiDAR has been around for about 20 years, more and more as-built surveys of all types are shifting away from the traditional methods to utilizing the latest in laser technology. As with every new production method, there is a learning curve, but once mastered, the entire process gets much smoother. And especially when incorporated with BIM technologies, the entire construction process can get a boost in speed, efficiency, and have a lesser environmental impact. That is it for chapter 3. Back to you, Cameron.
All right, thanks, Greg. And so now that you've collected the measurements in the field, it's time to create those actual plan sets. Finally, it's important to keep these organized and concise, but at the same time, leave room for notes, building code information, etc., just so that they can be used for design layouts, demo plans, construction documents, etc., as we discussed earlier. So drafting from the traditional method. So we're going to need to switch gears back to that. I know we've been talking about scanning, but let's translate these sketches now into great as-built plans. So drafting from sketches. So first order of operations is probably just organization as a whole. So what our method was get an easel, planting those next to your station and just kind of firing away. Kept things kind of organized and clean at your workstation. And then from there, it's a pretty straightforward process. So use a vector-based drawing software and draft to full scale, entering actual measurements from your on-site sketch. If you are modeling in Revit from a sketch, it's a little more difficult, but it's not impossible. In Revit, you're more building rather than drawing. So you'll often find that you'll need to let the model kind of dictate certain measurements rather than kind of holding all your own measurements that you took on site. And so now for a floor plan where you would typically start, you'll be using primarily the line tool in combination with whatever blocks that you've created. And then start with the perimeter line, and that usually comes first, as it does in the field when you were measuring. So starting with interior plan types, you'll want to draft your walls first, then move on to your windows and doors. If there are multiple levels, this is a very important point. You'll not only need to draft using your own measurements, but also be very cognizant of like stairwell walls, exterior faces, things like that of the structure, just to make sure that they all line up exactly as they probably do in real life. And so once those controlling items are done, you can draft in with probably a lesser degree of precision, cabinetry, plumbing fixtures, appliances, etc. For an electrical and reflected ceiling plan, it's much the same. So follow with what you've sketched and measured and just add the items one by one. And so now moving on to roofs, elevations, and sections. So you'll need to have at least sketched the behavior of the roof correctly in the field, or at the very least by using a nice clear satellite photo. And so this means all the hips, valleys, ridges, direction of any slopes. This and the measured length of all overhangs should get you to a place where you can draft the roof plan in plan view. On that same roof sketch, you'll need to have also collected all of the height information. So this is often achieved by using a zip level, which we talked about briefly earlier, and getting on the roof to take all needed height readings. That said, there are other methods to getting this information, such as using an angle finder, a level, and using various functions of a disto laser. And so drafting elevations, that'll come entirely from your floor plan and roof plan sketches. The one only exception is, maybe those special sketches where you showed certain aspects of ornamentation on the exterior. But drafting elevations will entail placing all windows and doors correctly with the correct heights. And of course, it's important to ensure that they correspond directly with the floor plan in those cases. Any decorative items that you sketched and measured can be drafted at this time as well. Drafting a roof and elevation view is one of the most difficult challenges, as it needs to correspond perfectly in all other elevation views. And then moving on to sections, once the cut location and directions are determined, you'll need to use the floor and ceiling information that you've sketched and measured from OnSite to complete these section views. So to draft the roof properly in the section view, it's highly, highly advised to have your elevation drawings finished first in order to use that same information to complete your section drawings. And so now I will kick it to Greg again to go over drafting from the point cloud.
All right, thanks, Cam. Okay, so we'll take a trip back to that laser scanning survey method and talk about doing the same drafting work, but using the point cloud data that we've created instead. So when drafting from a point cloud, the first thing you'll need to do is get into your drawing environment. Point clouds can be imported directly into AutoCAD or Revit, as well as other architectural software that supports point clouds. One note, if you use Autodesk products, you will need to use an application called Recap to prepare the point cloud to ensure it works with their entire software suite. So once you get in there, drawing from point cloud in CAD is pretty straightforward, but it does take some getting used to. There are a lot of options in CAD to color, slice, crop, move, rotate the cloud in all kinds of different ways. And you'll need to use the view cube to regularly adjust your UCS orientation properly to work with the cloud in those different positions. And then point clouds are really ideal as-built data sets for creating Revit models. But the Revit point cloud tools can sometimes feel a bit lacking. If you're making a 3D model, it only makes sense to work from a 3D point cloud to create an accurate model to kick off your designs and planning. So the tools for visualizing the point cloud are definitely not as robust as they are in AutoCAD, which is kind of weird given they're both sort of these 3D environments. But nevertheless, point clouds and Revit really do go hand in hand. Okay, so CAD drafting from your point cloud, looking at floor, electrical, and RCP. So let's talk about drafting these plan items from a cloud in AutoCAD. So as mentioned, when drafting in CAD from a point cloud, you'll want to ensure that your cloud is positioned orthogonally so that you can use the ortho function to draw your CAD lines in nice 90-degree angles when needed. Positioning your point cloud on the Z-axis in CAD is also desirable for a number of reasons. You should be able to derive all of the walls, doors, and door swings straight from the point cloud. Even window information can be found as well once you get very comfortable with manipulating your point cloud in your drafting software. Many scanners will not pick up some smaller items, especially if they're flush with walls or ceilings or hidden behind furniture or other objects. So trying to locate them in the cloud can be very time consuming. In that case, it's often better to revert to the traditional method while in the field and just sketch and measure some of those items. Even with the best scanner on the market, there's almost always some manual measurement required for every survey to get all of these items, particularly the electrical and RCP items. So now let's get into drafting other views, such as an elevation from the cloud. Now this is where there is a huge advantage in having a complete point cloud for drafting. Provided that you are able to access the roof in scanning, then you'll have a complete picture of not only the roof behavior, but also every single height that you'll need to properly draft your roof, exterior elevations, and any section you might need. So unless you're using a scanner with very, very high precision, for exterior elements, it is recommended to revert to those traditional methods to sketch out some of those ornamental items that you would like to include in any drafting. So as you saw some images of, point clouds can definitely be used to draw 2D plans easily, but they really shine when a 3D Revit model needs to be created. So first, just a little bit about Revit models and the level of development. Since Revit is an extremely powerful tool that can store information on every assembly within a given structure, the level of development system was created for the AEC community to describe different levels of BIM models and the use cases for each level. So this set of standards gets into the precision, the construction detail, and the overall refinement of each set of objects in your model. So for example, level 100 on the simplest end, it's just a single solid 3D mass of an object or even an entire property. Level 500 on the most complex end is so thorough that the model of the building is essentially a virtual version of the entire structure: nuts, bolts, bolt threads, bolt diameters, bolt lengths, washers, and all. So when modeling as-built plans, somewhere between LOD 200 and 300 are the most practical levels for a light and usable Revit model. So even though laser scanners gather a ton of data out in the field, you're still assessing a structure from the outside. All the interstitial spaces are inaccessible and their construction cannot be assumed. So taking it to something like that LOD 500 just isn't even really an option. So for example, an LOD 200 electric plan in Revit will look a lot like a 2D electrical plan in CAD, even though the rest of the architectural model is in 3D, because that's just the way the LOD standards set that for LOD 200. However, in LOD 300, electrical items and other structural elements are fully realized in that 3D Revit model along with the rest of the architectural model. In the case of exterior elevations like this one, you'll use the point cloud, and that will make it easy to make sure that the finish grade is accurate along the face of the house. Now, this can be achieved without going into all of Revit's topography tools and can be done with some simple masking and model line tools to help hide unsightly Revit artifacts you may not want to see in a clean elevation. BIM as-built and final models look beautiful and interactive, but there are many more advantages to having a BIM than just a BIM as-built than just a presentation. So the as-built BIM model can be viewed in multiple phases, so you can easily switch between existing or the as-built, demo, proposed, and even alternate proposed phases. Moving from the design phase to the construction documents phase of a project is far more efficient. Having an as-built BIM model can make it easier to understand a project that you haven't visited yourself, since you can cut sections, view interior spaces, and review roof massing all in 3D right there in your office. And some say that Revit offers a more intuitive design experience and allows users to present 3D images at the planning stages to the owner or planning departments. So to sum up this fourth and this final chapter of this presentation, drafting from sketches into CAD is a pretty straightforward process. It takes time to become efficient, but you'll just be entering measurements into CAD straight from your sketch sheets. Modeling into Revit from sketches can be done, of course, but you may find during modeling, you'll need to ignore certain measurements in lieu of letting the powerful software build the model properly. Drafting from a point cloud in both CAD and Revit means that you'll be importing the point cloud itself directly into the software and essentially tracing or placing components right on top of the cloud to create your set of plans. And with that, thank you, everyone. Back to you, Cameron.
Yeah, thanks, Greg. So that concludes the presentation portion of this, but I did quickly want to ask one last question, and that is, and this is an audience question, so please do share your answers in the chat. This is not a poll. Approximately how long would it take your team to measure and draft a 1,500 square foot single family residence? So let's see those answers pop into the chat here. So how long would it take your team to measure and draft a 1,500 square foot single family residence? Two people, 4 hours, 24 hours. I'll leave this up another few seconds and hopefully we get a few more responses. 12 hours, 2 days. I am my team. Yep, that's a common one. Thanks, Rick. And yeah, any further answers there? 1 hour, 10 to 12 hours. A lot of span there. It's always interesting to see that high and low number.
Yeah, Marcos Garcia's got his process
Yeah.
down.
Yeah,
That's for sure.
absolutely.
Yeah, I think I could get back in the old days. I was probably about 30 minutes in the field and maybe 30 minutes drafting if it was just a floor plan
Just a
of a
flip.
house that size, just a floor plan. Yeah.
Yeah.
Anything
That's
more
good
than that,
stuff.
and
Yeah.
then it gets
Maybe
nuts.
part of this question too is, plan types, right? Because that can
Yep.
obviously skew things.
Yeah.
All right. So that does conclude everything. So before we get to Q&A, I did want to touch on the attendance real quick. So I think it's probably way up in the chat now. I see it now being entered again. So go to that form, fill that out, make sure you get your learning units. And so now I do have a quick question before we jump into Q&A. Your questions, our answers. But my question for you is, when you went to school, and go ahead and type this in the chat as well, when you went to school for architecture, did you have any sort of classes that you could take on AsBuilt, how to properly measure buildings, etc.? Probably have an idea on the answers here, but yeah, let's see some of those in the chat. A lot of
That's why
no's.
that's why you won the raffle, Alexandra. It's because you had that AsBuilt class.
Yeah, I think I've seen one yes. Neither did I. So let's add me to the mix. Didn't even know what we were missing. Yep, us too, William.
Hey, Cameron.
Right. Yeah.
Christine with Long Beach South Bay. Why don't you go ahead and stop sharing your screen so we
Yes, of course.
everybody who's here in case someone's raising their hand with questions.
Yeah, we'll open it up to questions. I'm sure. What's timing looking like, Christine?
We got 1 minute to 1 p.m. So we can stay on longer if anybody wants to ask you guys some deeper questions.
Yeah, and if we aren't able to answer any questions, I know we are running out of time here. We're more than happy to answer any questions after this. Feel free to reach out via email or phone. I think Abby's punching that in the chat right now. So, any questions now, though?
I don't see any hands raised.
You're making it too easy on us.
We've got one here, guys. Can you measure if you have moving bodies around the place you're measuring?
Yeah, I mean, it's doable. Greg, I'll start off. I mean, it's certainly doable. It's not unforeseen to have people, pets, things like that. Moving objects such as, people, cars can kind of skew some things, but it's certainly doable. And Greg, I'm not sure if you wanted to elaborate on that at all.
Yeah, for laser scanners, when you're using terrestrial scanners, it's a little bit easier if there are a lot of moving things around. The mobile scanners, moving bodies typically aren't too bad. If you have a big box truck or something that's like really big that's moving or following you, I had one following me once, which was very weird and scary, but that'll definitely throw off your data a little bit. But for the most part, you can work around moving bodies. Yeah. And then I do see a question, what's the best way to align a Revit wall to the point cloud? That is a great question. So, I mean, the first thing I would recommend, as much as possible, before you even start the project, make sure to get your point cloud as aligned as possible using the rotation tools in Revit. So that everything is ortho. Revit really doesn't like walls that are slightly off 90 or off 0 or off 45, off those kind of, that kind of polar grid. So as much as you can do to get the point cloud ortho, so all of your walls are lining up, is the best way to start. From there, if you do have a wall that's slightly off, but you want to show that it is, that it is ortho, like say it's, 89.9 degrees versus 90, you'll basically want to still leave that wall at 90 degrees, but kind of put it in a place where you're equally distributing the error on both sides. So you've got like an inch off on one side and an inch off on the other. And whoever that is from Jeanette that's asking, if you want to talk about that more into detail, I mean, I'm down to get into the nitty gritty with you and get some screen shares going and talk about it. So just feel free to reach out anytime.
Yeah. I'm not seeing any other questions. You're right, Greg. They made it easy on us. Oh, Jeanette is going to hold it.
Uh-oh, they're holding. All right.
I hear the phone ringing already. Well, I think that's probably it. People are filing out. So thank you, Christine. Really appreciate you letting us do this and look forward to working with many of you guys in the near future here.
You're very welcome. Thank you. Great presentation.
Yeah, thank you.
All right. Thanks, everybody.
Yeah, thank you, guys.
Have a great day.